So I'd like to welcome you all to our first ever podcast for GOM series. In a run-up to the third Lightweight Vehicle Manufacturing Conference 2016, I'm joined here by Greg Peterson, Senior Technical Expert from Lotus Engineering. It's the US division of Lotus Group. Greg, thanks so much for joining me here. How are you doing?
Good morning.
Good morning. Greg, well, thank you again. I'd like to start with the first question, and it's going to be a really easy one. So you've got an impressive track record within the automotive industry. Could you give our listeners a brief overview of your career history and the key achievements to date?
Sure. I started my career at Pontiac Engineering and eventually went into CPC, Chevrolet Pontiac Canada, Advanced Vehicle Engineering, and then after that I left GM in the late 80s and went into Tier 1s where I worked in a variety of positions, solid-state electronics, plastics, as well as Lotus and some Chrysler work. Mm-hmm. In terms of key achievements and things that I really think where they push the envelope, the first one would be the Fiero, which was GM's first mid-engine two-seat sports car. I was the HVAC engineer, and we had a lot of issues with that car, as we'd never done one like that before. And eventually, with the help of a very good team, we were able to basically make that the best car in GM for AC performance. After a lot of work by everyone, that was rated by the AC subcommittee, an independent organization within GM of all divisions, as the best car in GM for AC. So quite proud of that. Another thing that I thought was really kind of leading edge was using what was GM's initial look into computational fluid dynamics. GM Research had developed a program, software, that basically was used to help the stock block Buick V6 be competitive in Indianapolis, and I got into that with the people that developed it and ended up applying it to AC ducts, where we were able to reduce the size of the ducts by 25% using that program, maintain airflow, and reduce the noise level. So it basically after that, GM was using that program in AC as well as engines.
Excellent.
I got into a company doing solid-state electronics. Some of the things that we did there were basically developed a device that took the engine throttling losses from a four-stroke gas engine and created electrical energy without using fuel. In other words, there was no change in brake-specific fuel consumption. And people didn't believe it would work. Our theoretical studies showed that it would. And we ended up testing in a GM dyno, and we developed 800 watts of electrical energy at the equivalent of a 70-mile-an-hour road load cruise without using fuel. So that was pretty innovative and good application of electronics and turbine technology to automotive. We also developed that same company a low-pressure modular electric air conditioning system that was a bit ahead of its time. I did some things at GE Plastics, and one of the things we did there was developed a door module that replaced 70 stampings with a single-piece gas-assisted injection molded part that was a tubular hollow part. I worked at Workhorse as I was the director of engineering for their chassis that they bought from GM. It was a medium-duty truck chassis, and there were a lot of issues with it. It didn't hold enough weight, and it looked a bit odd, and it wasn't particularly good handling. And we developed that car, that chassis, into a very good handling chassis. I actually hired a race car engineer to work with me on it to tune it. We did things like lateral acceleration tests and slalom testing to quantify the improvements we were making, and we put the whole thing into production in 6 months, which the suppliers told us it would take 1.5 to 2 years to do. So that was a lot of fun.
Yeah. Well,
that's background.
Well, that's really impressive. It really looks like you kept yourself busy over the last few years, and very impressive achievements indeed. So how did you get actually interested and involved in the automotive lightweighting? Could you tell us a bit more about that?
Well, I got interested in racing. I was racing many decades ago when I first started working at Pontiac, and even as a student I got involved in racing. And lightweighting is obviously key to making a car go faster, and I just simply started applying what I was doing on the racetrack to automobiles. A couple of examples at Pontiac, I used to always complain about how big and heavy our seats were. I did things like complain about using die-cast emblems, which weighed about 1.5 pounds, saying, why don't we replace these with, 4 ounces of chrome plastic? So it just became ingrained in me to be through the racing to use lightweight. Also, Lotus cars had a role in my interest in lightweighting, as their 4-cylinder cars in the 1950s would outrun our cars that had 4 and 5 times the displacement. Our V8 cars couldn't stay with the Lotus Elite on a road course, and the reason was just the Lotus was so much lighter that it had a better power-to-weight ratio, and the lightness helped handling and vehicle dynamics. So that was really how I got interested in automotive lightweighting. It's just always stayed with me.
Excellent. Well, it's really, really interesting. And you've been supporting the GOM initiative pretty much since the beginning, 6 years ago. What do you actually like about the series, and what benefits does your participation bring to yourself personally and to the company?
Well, I think the key to GOM is that you bring together a forum of key industry people who are all pushing the envelope. And although we can't talk about confidential things, we can certainly share things that are helpful to each other and pushing the envelope for the entire industry and giving perhaps impetus to companies that are somewhat conservative or more conservative than others in pushing the envelope to get lighter weight, better performing vehicles. And to me, it all ties together in terms of a lightweight vehicle is going to be a more efficient vehicle, and that means not only better dynamics, but also means better fuel economy.
Mm-hmm. Great. Well, we're glad that there is some benefit to the industry with the GOM initiative, and hope that's the case going forward. And can you tell us what lightweight materials or solutions are you particularly excited about right now? What are your major interests there?
Well, I'm really excited about the potential for carbon fiber in particular, combined with structural adhesives. We've been doing a lot of projects with those materials. The only one I can talk about that's in public domain was the Icon A5 aircraft, where we engineered the interior for that plane. And our target there was we had to do the whole interior with a mass of about a single front seat in an automotive passenger car. So we had some severe constraints, and we made the carbon fiber show surfaces the structure, and we're able to meet that mass target on that plane. It's a beautiful plane.
Excellent.
But that's one example. Another thought on this question is talk about low energy joining. I think that's very key to the future of being able to make a lightweight vehicle and save some money in the joining process by using less intensive or energy intensive sources of joining. And that includes not only structural adhesive, but there are other processes out there that are being developed that are quite good in terms of having excellent strength and durability, but yet not using nearly as much energy as our traditional resistive spot welding.
Good.
I think there's a huge opportunity to make using these materials to make a very lightweight vehicle that can be gas-powered and still get very, very high fuel economy. Talking 80, 90 miles per gallon on the highway. I've done a lot of modeling on these types of vehicles, and do it cost competitively. If you think about a car that weighs, say, 1,200 pounds instead of 3,000 pounds, that's a lot of material that you're not using that you used to pay for. So I think there are some opportunities by looking at things maybe a little differently than we have in the past of using these ultra high performance, ultra lightweight materials that appear more costly initially that really can be used. As an example, one study that I did, we started out with a cost disadvantage on a material dollar per pound basis of 16 to 1, a 16 to 1 cost disadvantage. And by the time we got through engineering the product, which took us all the way through manufacturing, we were able to get that 16-to-1 disadvantage down to a 1.3 disadvantage. Plus, we added a lot of utility and increased the size of the structure by 50%. So I think when you start applying these types of approaches to automotive, it's not obvious, but I think it's certainly possible to do an ultra-lightweight car that gets excellent fuel economy and do it at a cost that we currently charge for inexpensive baseline B and C class vehicles.
Good. Well, that's really interesting. We certainly look forward to hearing about more of your experiences at the conference where you will be sharing some of the other work that you've done. And what is your, probably one of the final questions, what is your favorite vehicle? I'm sure everyone is keen to know.
Well, outside of Lotus cars, of course, my favorite vehicle is a Ferrari 275 GTB 4-cam Nart Spider. Nart is the North American racing team. They only built 10 of them. It's just a gorgeous car with a V12, 6 carburetors, 160-plus mile an hour. Quite a car in 1967.
That sounds like a really good car to me. And how do you, probably just to wrap it up, how do you see the automotive industry in 10 years' time? What's your vision on that?
Well, my hope is that the automotive industry is going to be leading the way to get customers off the grid, whether it's electrical power, gas power, or at least much less dependent on that. I would like to see, and I'd like to hope that we will have affordable electric vehicles that have exciting performance. I mean, just look at some of the Tesla models. The Tesla Roadster would outrun our gas-powered Lotus Elise that it was based on, and yet it had all-electric power. I think that it's very important for automotive to keep aligned with the solar cell industry. Some companies have offered solar roofs with their vehicles, with their EVs, and I would like to see that trend continue. But ultimately, I'd love to be able to drive home every night, have our customers drive home every night, plug in off the grid to their solar panels that are on their roof, charge the vehicle up, and drive it into work the next day without worrying about range on it. I certainly think that's a possibility. I also would like to think that we'll be doing cars that are ultra lightweight with gasoline engines, small gasoline engines that have excellent dynamics, reasonable acceleration, get 80 miles per gallon on the highway, and cost in the $12,000 to $13,000 range as an MSRP to start. That's what I really would like to see, and hope that the automotive industry can do that.
Well, let's wait and see whether your predictions come to life and whether that's the case in 10 years. Greg, thank you so much for taking time. It's been a pleasure, and it was very interesting to hear about your experience within the industry. And we'll be having more discussions on the topic of lightweight vehicle manufacturing on the 24th and 25th of February at MGM Grand Detroit. Greg, thank you very much once again. You can find more information on the conference on www.global-lightweight-vehicle-manufacturing.com. Greg, thank you very much.
Thank you, Natalia.
Thanks, Greg.